Multivariate analysis of variance, aka a MANOVA. So we're going to make a quickie video on how to run a MANOVA in the SPSS statistics software. We're going to use the data from one of our previous study, the rat study. So the DV1 is sit-ups, DV2 is push-ups, and as you know already, a MANOVA has to have at least two DVs, somehow logically related, and they have to be correlated, but not too strongly correlated. In other words, the correlation has to be less than 0.8. So we will find all this stuff out in our MANOVA assumptions. So there's the two DVs, and the IV, number one, is the drug dose. There's three levels, right? 0 milligrams, 10 milligrams, 20 milligrams. And IV number two is the smoothie size, right? Small and large. So that's what we're going to try to see if there's a significant difference between the number of push-ups and sit-ups, which both kind of define the fitness of the rat. So there's the logic between hooking up these two DVs, is they both kind of describe fitness, and see if any of the drug dosage sizes or the smoothie sizes has any significant difference with the outcome of the DVs. So let's get right to the SPSS. Please hold. So the data has already been entered. Our IV drug dose has 3 different levels. Our smoothie IV has 2 different levels. Our push-ups are a scaled variable, right? That just means it's a regular counting number, as well as our sit-ups. And our 2 categorical variables, bam, 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 are the IVs, right? IVs, same with MANOVAs and ANOVAs. The IVs always have to be categorical or nominal. Okay, let's take a quick look at the data view. So a 0 is 0 milligrams, 1 is 10 milligrams, 2 is 20. Smoothie size, 1 is small, 2 is large. And here's the rat push-ups and the rat sit-ups. And we just put an ID number in here just to count how many rats there are. Okay, so let's go ahead and get started. Step 1, we always need to check the assumptions of each study, not just for a MANOVA, for every statistical study. We need to look at the assumptions of a MANOVA, and the number one assumption is sample size. So how do we find sample size? The minimum number of sample size for a MANOVA has to be that each cell of the analysis, and I'm going to draw you a little picture here in a second, the minimum number of subjects per cell has to be at least the same number of DVs or greater than, okay? So since we have 2 DVs in our study, that means our cells have to have a minimum of 2 DVs. So I'll show you how this works. The first IV is the drug dose. And as you recall, we have 3 different levels. Bam, bam, bam. So I'm going to make my cells here. Correct? So we need a minimum of 2 subjects per cell. Okay? Right? The minimum has to be the number of DVs. So we got 2 DVs, so we have to have a minimum of 2 people per cell. And in our study, we have 6 per cell, right? We have 6 rats in each of these little groups. So we did not violate the sample size here. So let's go back to the other IV, right, with the 2 smoothie sizes. All we have is a small and a large. Same thing, we need a minimum of 2 per cell, but with this one we have 9 per cell. So we're good to go. We did not violate the assumption of the sample size. So now let's get back to the SPSS. Number 2 is normality. We're going to go ahead and check the normality of the DVs. Okay, we're going to go to Analyze, Descriptive, Explore. Get in there, you. Explore. Okay. Let's reset this. Boom. So we want our DVs in the dependent list and our IVs in the factor list. And let's see what we got option-wise here. So we got to be careful here. We're not going to do outliers yet. That's part of the assumptions. We're going to check that with what we call the Mahalanobis test later. And we're going to click continue. Let's check the plots. Histogram is good to look at to see if it's skewed or not. We don't need the stem and leaf. And that should be okay. Options, don't need that. Click OK. So here's the explore data, right? There's all the numbers in each group. And here's the number of push-ups, the means and the standard deviations for each of the different levels of the drug. We don't really need that. I can see right off the bat that we have some kind of large numbers in the kurtosis, which could affect our normality. This one right here is scaring me, right? It's over 2. And that could mean that it's going to be kurtotic. There's another one that's kurtotic. So it looks like maybe 1 or 2 of these might be normal, but let's go ahead and look down at this test, right? The Kolmogorov-Smirnov test. So here's the push-ups under the 3 different drug levels. And yes, we do have some normality violations for the 10 milligram and the 20 milligram. Okay. But the rest of them all look pretty good. So for the sit-ups and the 0 milligram push-ups, they're all pretty relatively normal. Now we got to remember that the ANOVAs and the MANOVAs are what we call very, very robust tests. So we're going to go ahead and keep moving on. This is not a serious violation of normality. So now let's check out the smoothie size. That first one was just the drug dose, so now here's the smoothie size. And again, it tells us how many are in each group, right? 18 for small, 18 for large. Let's look at the overall descriptives. Can't help myself. And there's the mean and the standard deviation. The skewness, kurtosis, not that bad, right? Not as bad as the other one. And they all look pretty good, so I'm going to bet that the tests of normality are all not violated. And according to the Smirnov test, none of them were, so we are good to go. Assumption number 3, outliers. We're going to go ahead and use the Mahalanobis test for that, so please hold. Your MANOVA is very, very sensitive to outliers. That's why we have to do a special assumption check just on outliers. And we're only going to check the DV, like always, because the IVs in a MANOVA are categorical or nominal. It doesn't make any sense to look for outliers in categorical variables. Okay, so let's do the quick Mahalanobis distance check. Okay, pay attention. There's an SPSS kind of a glitch. In order to use the Mahalanobis distance function, we have to make a fake ID because the Mahalanobis test is under the regression part of SPSS. So regression, we need 2 variables to compare. So one of them is going to be the DV, of course, right? So we're going to do the sit-ups and the push-ups. So we created this fake ID, fake IV, and we're just going to call it ID, and we're just going to number them 1, 2, 3, 4, 5, etc., etc. Okay, so those are the variables. So watch closely. Okay, so we're going to go to Analyze, Regression, Linear. Okay, this is where it gets weird. So that new variable that we just made, it's just the counting 1, 2, 3, 4, 5, that goes in your dependent box, and your 2 DVs, the push-ups and the sit-ups, goes in your independent box. And the only thing we're doing in this function is doing the Mahalanobis. So we don't need any of the statistics or the plots of the options, but we need to find the Mahalanobis. It's under Save. And there it is right there, Mahalanobis. Cooks does the same thing, okay, but again, we're just going to work on the Mahalanobis. And that's going to be it. So let's click Continue way down here. And then OK. So again, remember, this is not a regression, so we don't really need to look at the regression stuff. We need to scroll down to the residual statistics table. There it is right there. Let me pull it up for you. Okay, under this table, the only one we're looking at is the Mahalanobis distance, okay? And we're going to go to the maximum number. So this number, 4.903, is the calculated maximum for both the push-ups and the sit-ups. Okay, it's going to get weird again. So now we have to look up a Mahalanobis distance critical value on a different website. Okay, so hold on. Let me pull that up for you. Normally, if you just type in Mahalanobis distance, you'll come to the Wikiversity page. Okay, and let's pull this over. So our DFs here are the number of DVs that we have. We only have 2. Okay, so our calculated Mahalanobis statistic was about 4.9, which is much less than this. So what that tells us is we did not violate any of the laws of outliers. Okay, so we are good to go on that. And just a little side note, when you get back to your data sheet, the one with the real numbers on it, you're going to find some new variables entitled Mahalanobis 1 and Cook's 1. Okay, so don't really worry about these. Okay, what this did was this is the information that the SPSS calculated for you when you ran your Mahalanobis test. So ours was 4.9. In other words, the biggest number for this Mahalanobis should be around 4.9 somewhere. There's 4.3, there's 4.9. So that's your maximum right there. But that's all this means. All right, the next assumption is linearity, and we're talking about the linearity between the dependent variables only, okay? So I'll say that again, linearity between the DVs. Very important, we want all of our DVs to be moderately related, okay, correlated, moderately. So that's somewhere between R equals 0.3 and R is 0.8. We don't want them too strongly correlated. That would run into something like multicollinearity, or it's just going to cause a problem. Okay, so we want all of our DVs to be moderately correlated. So we're going to use a function called the matrix of scatter plots. What that does is it takes each of the DV from each of the separate levels from the IV, and it makes a bunch of little scatter plots. Bam, 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 bam. So we should be able to look at a central linear pattern, hopefully. Sometimes it's hard to tell. But we're looking for a moderately correlated DVs in there. So let me show you how that's done. All right, to look at all the possible pairs of the DVs, you're going to go to, let's scroll this down. We're going to go to Graphs, Legacy. Move this over a little bit. We're going to go to Graphs, Legacy, Scatter Plot. We want the matrix scatter plot. Click Define. So here's your box. This is the matrix variables. This is where your DVs go. So ours are the number of push-ups and a number of sit-ups our little rat friends can do. Okay, one of the drawbacks of SPSS is it can only run the IVs one at a time. So we're going to go ahead and put the strength dose there. Okay, and then we click OK. Let me scroll down and get this OK for you. Where's my OK? Come on. Sorry, technical difficulties. Click OK. So we're going to get our scatter plot boxes. Yeah, relatively linear, right? You see that? Relatively linear. Not bad. So that tells us that for the drug doses, right, the linearity is pretty darn close. Okay, so it's acceptable, right? You could see a straight best fit line going through these guys. So now we're going to repeat it again, but this time we're going to change the IV. So we're going to go back to Graphs. Let me move this over a little bit for us. Graphs, Legacy, scatter dot, matrix, define. We're going to take out the strength, put in the smoothie, and click OK. Click OK, and this should give us the second set of scatter plots. Again, this is for smoothie size, and again, it looks pretty darn good, right? You could easily see that these dots tend to form a relatively straight line. Okay, so our fourth assumption of linearity of the DVs has not been violated. Assumption number 5 is the homogeneity of regressions. We're going to go ahead and skip this assumption because this is a very complex assumption. The only time that you would use it is if you thought that the DVs should be in some specific order. That's called a step-down MANOVA. I'll say that again. If you think that DVs should be put in some kind of order, then you would run this homogeneity regressions test. But because it is such a difficult thing, we're going to refer you to a book. It goes over homogeneity regression between the DVs in this using multivariate statistics 5th or 6th edition of the Tabachnik. The Tabachnik is a very popular name in statistics, okay? So this is also explained in the blue Keppel textbook, and that's on page 320, I believe, of the current edition. And lastly, if this does need to be done, if for some reason you believe that the DVs should be placed in some kind of order, then we suggest that you Google it. There are some good websites out there that will show you how to do it. It has to be done in syntax, that's the code of SPSS, but it is doable. Assumption number 6, multicollinearity and singularity. Remember that our DVs have to be correlated, but the correlation has to be somewhere between 0.3 and 0.8. It cannot be greater than 0.8. That has to do with the multicollinearity issue as well. So to check the multicollinearity between the DVs, we go to Analyze, Correlate, Bivariate. And our DVs in this one are the push-ups and the sit-ups. Okay, DV number 1 is a push-up, DV number 2 is a sit-up. And we're going to do the Pearson correlation. Click OK. Okay, here's our correlation table. If I can get this up here for you. And it's almost perfect, right? So it can't be over 0.8. So that means we do not have collinearity between the DVs, okay? So that's how you check for multicollinearity. Now, singularity is if you tried to combine these DVs and made a new DV out of the sum of other DVs. That's violating the singularity assumption. So for our example, let's say we made a new DV and we called it both ups, okay, which was the sum of the sit-ups and the pull-ups, push-ups. See, that would be bad, right? So that would violate the assumption of singularity. So that's it for that assumption. Assumption number 7. This is the last assumption. We're saving the best for last. But this one's the homogeneity of the variance hyphen covariance matrix. Let me show you what that means. The good news about assumption number 7 is that you have to run the MANOVA first. Okay, so let's go to MANOVA land. Analyze. General, linear, model. Multivariate, because it's got more than one DV. All right, our DVs are push-ups, sit-ups. Our fixed factors are our grouping IVs, drug dose, smoothie size. Okay, we're going to look at the model. Okay, this should be preset. You always want a full factorial, and you always want the sum of squares to be type 3. And again, this is a preset. Click Continue. We want to look at the plots to check for interaction. We're going to do them both, okay? So let's make the drug dose the horizontal. That's your x-axis. The smoothie size will be the y-axis, okay? So that's your first one. And then we're going to do it backwards. We're going to make the smoothie size the horizontal and the drug dose the separate lines. All right, both of these graphs are going to give us the same information but from a different perspective. You'll see what I mean here in a second. So hit Continue. Now you go to Options. We're going to do the drug dose, the smoothie size, and the interaction between the two. We always want the descriptives, effect size, power, 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 homogeneity of variance, right? Click Continue. You're good to go. Click OK. Keep your fingers crossed. So here's the printout of our MANOVA. It's Okay, so the first box tells you your IV, the different levels of your strength drug, and your different levels of your smoothie size, how many people are in each group. Next box is your descriptive statistics. Those are all the means and standard deviations and the sample size broken down by their little subgroups. And you can see huge differences in here, right? And this is your number 7 assumption of homogeneity of covariance and variance matrix. This is called the box M test. So like the Levine's test and the normality test, if this significant number is small, that means you violated the assumption, okay? But with the box M test, it's a lot more sensitive. Instead of the 0.05 cutoff, this number has to be less than 0.001, okay? So unless this significance number is less than 0.001, you did not violate the homogeneity of the variance / covariance matrices. Yay, so we can continue. Okay, the next box is the multivariate test, okay? This box doesn't really look at the difference between the DVs at all. It's simply looking at the levels of the IVs, if there's a significant difference of the levels of the IVs. So depending on which book, which professor you're using, most of us use the Wilks Lambda, but some teachers will use the Palais trace, but you should get the same response on both of these, okay? So the intercept we never look at. Here's the drug dose. That's the first IV. So was there a significant difference in both of the DVs when it comes to the drug dose? And yes, there's a significance of less than 0.001. Let's drop down to the smoothie size, right? Was there a main effect of the smoothie size? No, not. There was no significant difference between the smoothie size. And let's look at the interaction between the two. Yes, there was a significant interaction between one of the drug doses and one of the smoothie size, okay? So that's good news, but that doesn't do anything about the DVs. That's just telling us about the IV different levels. So yes, difference in the drug dose, no difference in the smoothie size. Yes, there was an interaction between one of the drug dose levels and one of the smoothie size levels. So here's our homogeneity of variance test, and neither one, right, the push-ups nor the sit-ups violated the homogeneity of variance, so we're on a good-to-go basis. Okay, the next box, this is your test of between subjects. This is your overall ANOVA box. These will be the numbers that you're going to use when you report it in your APA formatting. Okay, so the overall corrected model, yeah, there's a significant difference in there somewhere. Don't look at the intercept, but for the drug dose, you see that? It breaks it down into the first DV push-ups and the second DV sit-ups. So it'll say, was there a significant difference between the drug dose groups with push-ups? Yes. And with sit-ups? Yes. See, it labels both significances, but both DV significances are listed under this one column. So this agrees with the multivariate test from above, right? Smoothie size, was there a significant difference between large and small in push-ups? No. Large and small in sit-ups? No. Again, that kind of agrees with the Wilks lambda from above, from the multivariate thing, so we already knew that. And again, there was a significant interaction there, okay? So we did good there. So remember, these are the numbers that you're going to put in your APA write-up of what happened, okay? Got it? So these should agree with your multivariate tests, and they do. So let's press on. All right, we're going to scroll down to our estimated marginal means plots. Okay, so this is how, right, the different strength drugs affect the different smoothie size, right? So the green one is the large smoothie. So apparently, for some reason, when you have a large smoothie and 10 milligrams of the drug, you are unable to perform. There's some weird combination going in there. But vice versa, if you look at the 20 milligrams with the large sample size, you skyrocket. So there's your interaction right there. So now let's look at the interaction of the smoothie size. See that? That's your x-axis. And then the different lines are your different strength drug doses. Right? So the blue one is 0 milligrams. So that means at that one, the smoothie size actually had a negative effect. At the 10 milligram, that's the green one. Same thing, that the smoothie size, again, made these guys do less push-ups and sit-ups. And then finally, the last one is the 20 milligrams. That one, combined with the large smoothie size, made these guys into super rats. Okay, so that's for push-ups. And for sit-ups, we should basically get the same thing, which we did. Okay, there's the strength drug 3 levels with the smoothie sizes. And there's the small and large smoothie size with the different strength levels. And they basically say the same thing. But one is based on the strength serum as the x-axis, and the other one is the smoothie size as the x-axis. So that's how you do a MANOVA in SPSS. I hope you guys enjoyed it and it helped. But that's the end of this video. MGZ, out.